We are rolling, great. We have a party tonight. It is at Club Ibiza. If you want to go, there are wristbands available at the registration desk. You can go and get one wristband. We believe that just about everybody who wants to go will be able to get to go because it's a rather large club, but nonetheless, if you get a wristband and decide that you don't want to go, give it to somebody who doesn't have one rather than just letting it end up in your luggage. There is a lock contest this year. It's not picking, but master key attacking. Learn how institutional locks work and how to attack them. Escalate typical user's door key into a master key effortlessly and cheaply. Lessons start at 11:30 today, contest at 12. There's also a game called Escalator Action, and top prize is a Shmoocon 2014 ticket. I also have some things to give away. I have a Shmoocon moose, t-shirts from Security University, there we go. A Shmoocon Labs notebook. And this one's not going to go very far because it's very sharp. A Snowpocalypse scraper. And also we have from Microsoft and University of Washington their game Control-Alt-Hack that teaches you how to do hacking things. For this, I want a question answered. So what was the first released version number of Windows NT? The 351. Come on up. I'm not going to throw it. I'll kill somebody. All right. So this is our first talk, Paparazzi over IP. It's by Daniel Menda and Pascal Turbing. Thank you very much for all getting up this early, and I'll hand it over to them.
Okay. So. Okay. Hello, everybody. Good morning. Thank you for getting up this early and showing up for our talk. So, as you see, we have not been able to modify the camera to shoot rockets, so we need to do this on slides. Apparently, there will be no demo. Okay, but let's go on. Who are we? This is Pascal. I'm Daniel, and we're both working for a German-based company called ERNW. We're some kind of old-school network geeks, so we've been messing around with protocols and implementations in the past years. We also got a nice blog with some upcoming news here and there, and we also run a conference in Heidelberg in Germany. As you can see on the slide, this is called Troopers. Okay, so let's get into the topic. We will first have a short introduction. So what is this talk about? What will you see? What's the consequences? Afterwards, we will have some looks at the communication protocols that the camera uses, first on the lower levels, afterwards on the service level, and then finally we will get some conclusions. Okay, so let's drop into. In the past few months, Canon released some higher class DSLR cameras, which are all got some built-in network interfaces. This technology is around for a few years, but it always was some additional accessory for the camera you needed to buy. From now on, all this stuff is built into the camera, so it's not anymore optional, and every camera will roll out with this stuff included. So this opens up some new interesting attack paths. We have chosen to take a look on the latest flagship model of Canon, which is the 1DX you see in front here. I also got a little nice screenshot of the camera, and yeah, some little bit of marketing. These are just two statements from the website Canon USA. And yeah, so they say the camera features a built-in Giganet Ethernet port to transfer the pictures directly to your client, like upload all the picture taken into the cloud, which is a good idea, isn't it? Also, there is some wireless transmitter, which is the additional accessory mounted to the camera here. As you can see, the gigabit Ethernet port is built into the camera, just the Wi-Fi need to be attached. But this will also change with the new generation of cameras. They will also get the Wi-Fi built in. Okay, so this is the gigabit Ethernet port. It's on the left side of the camera. And there is also a waveLAN adapter for that camera, which is mounted on the one in front. Okay, what's our target? So let's say there are a lot of people running around with this kind of cameras, taking all kind of photos, and these are sometimes really important photographies. And yeah, so what would happen if one is able to get the real footage, the unedited footage, where all the faces are unscrambled, all the penises are shown, and yeah. So what would happen if one would be able to upload some footage to the camera, and afterwards pointing to the cameraman and saying, "Oh yeah, take a look at his camera. He took some really bad pictures." You could imagine what kind of picture that would be. And third point is, what if one could turn the camera into a surveillance device? Like monitoring all the stuff the photographer is doing. Like this camera right now is mounted here. There is no one there operating the camera, but still, what would happen if one could just take the footage from this non-operating camera in front and just take a look? Yeah, okay, we will see. So, first of all, we took that camera, plugged it into our network, and took a look at the underlying transport protocols. So this camera obviously speaks Ethernet and wireless LAN, and also standard TCP/IP. It just features IP version 4. There is no IP version 6 implementation at the time. That may follow in the future. Okay, so what's with all the traditional attacks? Okay, on layer 2, it's really easy. ARP spoofing is possible. There is no feature like sticky ARP entries, which are not able to be modified while the camera is running. So you can easily ARP spoof the camera on layer 2. So getting man in the middle once you're in the network is absolutely no problem. Also, we recognized, as this is an embedded system, it doesn't get much computing power. So when you send about 100 packages, we tried this with ARP packages. Once you send about 100 packages per second, you just got a denial of service of the whole network stack. So it stops answering to ICMP pings, it doesn't accept any new TCP connections and all that kind of stuff. So, okay, that are the results we kind of we expected, but yeah, that's nothing really special. So we moved on to layer 3, layer 4, which is the TCP/IP communication. This is where all the services are running about, and okay, we figured out what could be useful in our attack scenario, and we tried, okay, yeah, TCP reset attack would be nice to just disconnect the connected client or a connected user, and that's easily doable. If once you're man in the middle, you also got the TCP sequence number, so a TCP reset attack isn't hard to do at all. Okay, after we looked at the lower levels, at the transport levels, we moved on and got into the services. So this camera features 4 different service modes, network communication modes, as they are called in the menu, which is the FTP upload for once. Then there is some DLNA mode. There is also built-in web server. And in the end, there is some proprietary tool, the EOS utility, which also uses a kind of proprietary protocol. It's standardized in its main features, but there are a lot of proprietary vendor extensions. So we will get into each of these points in detail. And Pascal will now start with the FTP upload mode.
Yeah. Hello from me. Oh, yeah.
Oh.
Is it the beamer or yeah. Okay. So this is the first mode we are introducing is the FTP upload mode. So what it does, or how you configure it, you configure the credentials in the server on the camera over the menu, and every photo taken with the camera is instantly uploaded to the FTP server. Of course, if it's connected to the internet. Yeah, this will be. And yeah, what are the downsides of FTP? FTP is, as we all know, high security, clear text protocol. And once you're man in the middle via up spoofing or something, you can sniff everything the camera is transmitting. So you can extract credentials and also the uploaded pictures from the TCP stream. And here is a short footage of how you get pictures from packet trace of FTP upload. So here you see is our PCAP file. We are extracting with TCP flow, a command line tool for Linux, every TCP connection. And then we use foremost a command line tool for recovery purposes. And it's processing every file in the folder, and it outputs everything it gets to an output folder with log files and also every picture it found. These pictures are, the same pictures the photographer transferred to the FTP server of its own or of its client.
Yes, sometimes you get the pictures a bit messed up because if you get some packet loss on the cable, or if you got duplicated packages, the tools are not that good to recognize this kind of behavior. So sometimes your JPEG output get a bit messed up, but it only happens one photo from the whole CF card. So this is really a small amount of the pictures which get kind of messed up. But that could be,
You could definitely fix that via Wireshark.
yeah, you could just use other tools which
of
recognize this kind of behavior. This was just a short proof of concept how to extract the JPEG footage.
Okay.
Okay, so far for FTP, nothing really new here. We all know FTP isn't the highest secure protocol at all. So let's move on to the next operation mode of the camera. This is the so-called DLNA mode. DLNA stands for Digital Living Network Alliance, and this is just a consortium of all the TV manufacturers, like camera manufacturer, like video camera manufacturer, and it just defines some guidelines for the file formats used and for the encoding used and like the resolution of the footage. So it's kind of a standardized environment. It's not a protocol itself because it uses protocols that are always also already in the wild. For discovery, UPnP is used, which comes in handy because UPnP is something you could sniff even if you're not man in the middle, because it's just communicated to some broadcast multicast address. So if you just have network access to the same network segment the camera is in, you will recognize the camera once it is in UPnP mode. So for the actual access to the camera, then HTTP and XML is used. So you get inside of the UPnP message, you get something like, okay, hey, I'm a camera, I'm speaking DLNA, and if you want to know my features, just get these XML file from my built-in web server, and everything, all my features are listed in that file. And from this file, you can start browsing the pictures and so on. okay, what is the problem with DLNA? First, there is no authentication at all. Second, there is no restriction at all. So I cannot authenticate who is accessing the camera, and I cannot regulate what he can access. So he's probably able to download all the images that are on the camera. Not only the images, also the video footage taken with the camera. And you don't even need some special software. Your browser could be a DLNA client if you know how to read the XML by yourself. So even it's not very hard to access. Okay, so those were the two boring operation modes because they're clear text and kind of unauthenticated by default. This is just a small giveaway. Okay, but now comes the interesting stuff, and Pascal will tell something about the built-in web server.
Yeah.
Which, by the way, is always a good idea to have a web server on an embedded device.
Yeah, web is the most secure place in the world. So this, the camera features a third mode called WFT server mode, which stands for wireless file transmitter server, which is actually the Wi-Fi adapter. On the other cameras, which are not capable of Ethernet or something, these server modes are built in the wireless adapter. And the Canon states about this WFT server, use a web browser to capture, view, and download images remotely. So, what do we want more? And let's have a look at what this web server serves. It's kind of a web application utilizing AJAX requests to be a little bit fancy and stuff. The web server itself is just capable of HTTP GET methods. There is no post, no head, no trace at all. It just responds with a 404 if you try to get ahead of your web server or something.
So as you see, a really advanced web server.
Yeah, it's an embedded device on the camera. It's not supposed to be a high-powered web interface kind of thing. And the first time, actually, this web application has authentication. It's authentication is authentication is good. Your landing page pops up an HTTP basic auth prompt to fill in your credentials, and after you're authenticated, your session is stored in a cookie. Nothing special yet.
Okay, that's good, isn't it? There is authentication, but okay, it's done via HTTP basic. That's not so good. And afterwards, the session ID is used. Okay, that could be good, but we will see.
Yeah, you actually, if you are man in the middle now, you can sniff the authentication because it's clear text and no HTTPS at all. But it is the session cookie is it's a cookie, and the cookie looks like this. So what is special about this cookie?
No, what's wrong with this cookie?
Is there something wrong with this cookie?
Oh, it's a cookie.
Yeah, cookies are good.
And it's called session ID, so.
And it has 4 bytes. This means there are just 56K possible session IDs, which we have to check. So this is the WFT server, and we just thought, WTF. So we just wrote a little tiny script to check all these session IDs, and it actually took About 20 minutes to check all these session IDs. It depends on the load on the camera. Sometimes it's 12 minutes, sometimes 22.
Yeah, sometimes you're lucky and getting session ID 1.
Yeah, and yeah, it's a camera. It's not meant to be a web server, so the web server is not very responsive. Sometimes you have to wait 1 second for a response. And yeah, we recorded a little demo of the brute forcing. Of course, not 20 minutes of brute forcing. We yeah. We took care that the session ID is not that great. So this video is real time, and yeah, I just fired up these little Python script, which is actually 6 to 10 lines of code with a little bit of eye candy, as you can see. And yeah, now it's time, and you see, session cookie is actually 3 bytes at this time. And we just browse to the camera. This is the IP of camera, and yeah, it says there is someone logged in, but it actually says every time there is somebody logged in.
Yeah, this is because we browse directly to the login landing page, which you only get redirected if there is a user accessing the camera already.
Yeah, the basic authentication is just on one page when you are directly browsing to the IP. So here we add our cookie to our browser. Just press F5 and accessing the camera control from our browser. Yeah, and now you're able to enter the live view mode, which actually pops up the mirror of the camera, and you get a picture every 1 or 2 seconds.
Yeah.
A picture here, and you can just that way turn the camera into a surveillance device. You can mess around with the configuration of the camera.
Yeah, you can, of course, you can download all the images.
Yeah, you can download all the images in the Viewer tab. And also, this simple control panel is just the same as this control panel, just without these configuration parts to view this on your mobile device like iPad or iPhone.
Yeah, we will get to mobile devices again later on.
And also, you can take pictures here with these trigger, and yeah, that's the what the fuck server mode. Yes, passt schon. So let's recap. We have full access to the live view of the camera, the stored photos, and the camera settings. The photographer is surfing, and we just fire our script and brute session ID. Maybe the server is not that responsive anymore for the photographer, but I don't think he's getting the point that we are brute forcing the camera. And what are the requirements to do this attack? Of course, the camera has to be in the WFT server mode. A valid user has to be logged into the camera. There is no valid session ID if there was no authentication before. And some minutes of time. And actually there is no session timeout or something like that. But the camera itself has
Yeah, even if you log out, your session will be valid.
yeah. And the camera has its own timeout to get the sleep mode or something.
If
And
you do not deactivate this.
Yeah, if you do not deactivate it. And actually then the session is dropped also.
Yeah, because I just hear it from the audience, there are no log files on the camera at all. So nobody will recognize your brute force attempt. There is some little menu thing which says, okay, give me the last error that occurred, but it always says the camera wasn't able to connect to a target. So this is just a generic error message, yeah.
Yeah, and no man in the middle at all at this point.
Okay, so let's get into the fourth communication mode, which is the EOS utility mode. I wrote a short subtitle which says, okay, AKA I want to be rude, because this is the utility. You see this is the client side, so this is actually the tool, which is at this point connected to the camera. You got the option to download the images, but you also got the option to get camera settings and remote shooting. So if you do this, this little window pops up. Oh, looks like the web server, the WTF server. So you got all the camera controls on the right, you got a nice live view in the middle, and from this menu you can also set, yeah, dear camera, please focus on this little thing in the background. I want to see this password written down on the monitor screen. Yeah, you can also zoom into the image. You can take a photo in high resolution, download the photo, so you will get the password if one is inside. So this mode allows the control of every non-manual control on the camera. So you can control the whole camera, except for the manual objective stuff, so you can't zoom in or out. Pictures can be up and downloaded with this transfer mode. So it's not just picture download, you can also upload some footage. And possible even more could be done. So yeah, I tried to get the sound recording working, because the camera records sound when it records movies, so there is a microphone built in. But I didn't figure out which of the proprietary Canon options to set in the transport protocol. This may be some future work. Okay, so this mode is absolutely magical. You just power on the camera, start the utility on your client, and everything else happens in magic. There are two broadcast protocols used for discovery and for communication, which is SSDP, the Simple Service Discovery Protocol, and again, multicast DNS is used. The underlying protocol is PTP-IP. I will get onto this later on. This is just used for the communication between the software and the camera. And you also need some initial camera software pairing. So both parties need to know each other, need to kind of handshake, so which is a good feature, a step into the right direction, because if it's done right, nobody should be able to get man in the middle. Okay, we will see. The pairing needs to be initially done before both components can communicate with each other, and they need to exchange the credentials. You need to put the camera into pairing mode manually via the menu screen on the back. And also the camera, after that, signaling the need for pairing via MDNS. Okay, that could be good, but could be bad. Think about you as the attacker seeing a camera in the network, just saying, oh yeah, please pair with me. Hello, is there any software? I need pairing. So you as an attacker could just jump in and say, yeah, I'm your software, pair with me. So that could be possible. Actually, it is possible, we did it, but that's the boring attack path, because you need to put the camera manually into pairing mode. So let's assume pairing already happened between the camera and the valid user's software. Oh, by the way, this is what it looks. It's just an entry in the multicast DNS saying, yeah, my TID is something 001 FFFF. This is the signal for I need pairing. So if the client software sees one of these multicast DNS packages, it just pops up a little nice pairing screen and sends some authentication credential to the camera. Yeah, this is what it looks like. Here the software just detected the 1DX. So you can see the MAC address, the IP address, and just need to click on it. Then on the back of the camera screen, there pops up a little message saying, okay, the computer with host name Mac PC is just trying to pair. Is this okay? Then you have to accept the pairing on the back of the camera menu, and there it goes. Okay, so the pairing actually happens via this PTP-IP protocol. In fact, the client software just logs onto the camera with whatever credentials the client software wants to use. And the camera accepts this connection and saves the credentials on the camera. Okay, so the authentication is always successful regardless of the credentials. And the credentials in this case should be the host name and the so-called GUID. I will get in a second to this. Okay, but first a little more detail on the protocol used, which is the PTP-IP, which just feels a bit like USB over IP. Because, yeah, PTP is the picture transfer protocol. So PTP-IP is the picture transfer protocol over Internet protocol. Really nice name. It's standardized in an ISO 15740, and it's standardized by the International Imaging Industry Association. Okay, so this protocol is more or less a wrapper for PTP. PTP is the picture transfer protocol, which was standardized in the same ISO by the same association, but it was mainly standardized for use over USB. So every camera uses PTP. There are a lot of like MP3 players using the same protocol to get the music files onto the device. Okay, so but this PTP-IP is mainly a wrapper for PTP. So it just contains a 4-byte length field, a 4-byte type field, and afterwards the data. Okay. Yeah. So no TLV type protocol, but a LTV type protocol. Doesn't make it any better. Okay. This is what the layering looks like. So you get PTP on top, which is the protocol normally spoken via USB to the camera. Then you got the PTP-IP layer. After that TCP is used, then there is some IP and some network below. Okay, now there is one really interesting packet in the PTP-IP definition, which is the PTP-IP init command request. This is the first packet sent from the client software to the camera. Just means, okay, dear camera, I want to authenticate with you. Included in this init command request is a 60-byte GUID and the hostname string. So these are the credentials exchanged via the pairing, and yeah, they need it for authentication. So my first thought was, oh, wow, a 16-byte GUID. This will be hard to brute force. And also, a hostname string, yeah, that shouldn't be that hard to get, because once you're in the network, you see, yeah, all the Macs are screaming around all the time. Yeah, my hostname is this and this, and also Windows boxes do this. Here also the lovely multicast DNS comes in handy. Okay, so remember, this is the authentication material we need to use to access the camera, which is a hostname string, which can be not indefinitely, but very long, and also the 16-byte GUID. This is what this init command looks like in hex. So you got first in red the packet length. Remember, it's little endian. Then you got the packet type, which in this case is the 0x01, the PTP-IP init command request. Then you got in blue the GUID, and you got in purple the host name, which in this case was just server. It's just a UTF-16 encoded. And afterwards you got a little trailer which just says, okay, the packet ends here. So, Okay, let's move on to the attack. We obviously managed to get access to the credentials, otherwise I wouldn't stand here in front and telling you all this stuff. So, okay, what's the process? First, listen for the camera on multicast DNS. It just pops up and says, yeah, hey, I'm here at the network now, I'm ready, you can access me. And that's the signal for the client software to pop up a window which says, yeah, I discovered a new camera. Do you want to connect to this camera? And so on and so on. Then, okay, we need to somehow get the authentication data in hand. Then we maybe need to disconnect the client, because in this mode the camera only accepts one connection. After that, we ourselves connect via PTP/IP, and then we're having some fun. Okay, so as I said before, the client host name should be easy discoverable, but in case it's not needed at all. The camera just accepts any connection with any given host name. So, okay, that was easy. Just use our own host name, it will work. Afterwards, we need the GUID, which now is the only authentication material left. Okay, it's also 16 bytes, quite long. But we figured out this GUID is not stored on the client side. So the client has absolutely no clue with what authentication material it should access the camera. Okay, that made me wonder, where is this magic 16-byte string coming from? As the software uses it to connect, but it doesn't store it locally, so something is wrong here. I figured out the GUID actually is broadcasted by the camera via UPnP. This comes in very handy because we don't need to brute force the 16 bytes anymore. We just need to listen for this multicast DNS, and again, it's the tid.canon.com, which once the camera is paired is a string like this. This isn't the UID, but it's obfuscated. So here is some lines of Python I wrote. You just take these multicast DNS information, you get the properties tid.canon, you just mix around the bytes for a little bit, and afterwards the GUID comes out. So remember this blue string? The EB7A789D. This is just what I showed you before on this slide. The EB7A789D, and so on and so on. So, okay, now we got everything to go to connect to the camera. But the camera only allows one connection, so if there is a client connected already, we need to disconnect this client. But that could be done via the TCP reset attack I spoke about in the beginning. Okay, you just terminate the client's TCP connection, the camera then falls back into the open mode, so it again accepts connections, and we just need to be faster than the client software to connect to the camera. But this is no problem, because we are sending the reset, and in the same moment we can send our SYN packet to the camera. Okay, so we have a little nice demo of this, and let's see if it works. So, okay, I wrote a little Python script, which when I launch it up, it just sits there and waiting for the camera to show up on MDNS. I will now turn on the camera because it's sleeping right now. And once I turn on the camera, it builds up the WaveLAN connection, it requests an IP address via DHCP, and afterwards it's starting broadcasting all the multicast DNS stuff and saying, yeah, I'm here. Okay, and there we go. As you see, I first found the camera, so I got the IP address, then I found the GUID, which was deobfuscated from the same multicast DNS packet. And then I just used libgphoto, which implements PTP/IP to connect to the camera. Okay, so once I'm connected, what I'm able to do, I can get all the camera configuration settings. So you see I got a nice lens mounted in the front. Also there is auto white balance, there is some exposure compensation, and so on and so on.
Yeah, and all the stored EXIF data like photographer name and
Yeah,
something
of
like
course. I can change all the EXIF data which will get written to the images. So I could set myself as the author of all the pictures. I could. Okay, but even more, I can not only access...
Question?
Oh,
Can you get to geolocation data as well? GPS?
yes.
It's
If-
also stored in the EXIF data, but yeah, you
There-
have to use the GPS.
There's a little problem, right? Because you can only attach one of these accessories, and this is either the waveLAN module or the GPS module. But the waveLAN module also features Bluetooth, so you could attach a Bluetooth GPS receiver and then get both again. So, okay. But anyhow, as you will see in the next step, oh, it failed. I was too slow, speaking too much. Okay, let's start it up again.
Boot in.
Does the camera cache its previous known location?
That's a good question. I have not worked with location data, so but the location data will be in the images. Okay, so we're connected once again. So I read the configuration data, and afterwards I'm getting a listing of all the files stored on the camera, and not only getting the listing of the files, I also start downloading the files. So you can see these are all the images I've taken in the morning, just to get you a little example of what can be done. And for a question, these are the raw images coming from the camera. So I took the photos in JPEG, so these are JPEGs, but if you configure the camera to get raw images, this will be the raw data of the image. And also both types of images, the raw type and the JPEG type, got nice little EXIF data, so you will find the image location in the EXIF data if a GPS receiver is attached.
And actually, the US camera.
So, okay, but that's quite nice to get the images, but we also, again, too slow. Yeah, the camera drops my connection if I don't ping it all the time, so it terminates the connection and runs into a timeout. So I'm just talking too much, showing too less. Yeah, right.
Wild true pone.
Okay, so we'll run through this again, waiting for the camera showing up. So there it is again. We read the configuration data. We take out all the image files. This again takes a second, as it only transmits with around 2 megabits. You see again, the images are coming right out of the camera. So, and once this is done, I can go further and can also get a little nice live view directly out of the camera. So, yeah. Okay. So now the camera absolutely is a surveillance device. So, okay, so what does this mean? Figure about some photographer just was on a big outdoor event. Yeah, think of the Grammy Awards a few days ago. And now he's sitting in a nice little hotel waveLAN and just uploading all the images either to his computer or to the cloud, as you like. And yeah, almost anybody which is connected to the same broadcast domain now is able to get his hands on the images or get a live view from the camera or also upload images to the camera. This depends a little bit on the operation mode of the camera, but you can extract all the images regardless of the mode. So, and maybe even more, we need to take a look at the sound recording, because that would be really nice if I also can turn the camera into a bug. Yeah. Oh, one word to the attack I showed you just a second before. Once I'm connected to the camera, I can tell the camera, yeah, please, dear camera, disable all manual controls. So you cannot turn off the live view from the camera's menu. You cannot terminate the connection, except for pulling out the battery. So, okay, what countermeasures are there? Yeah, there are not really countermeasures. You can hope that Canon improves the protocols and the authentication, but this, I'm not sure if this will happen. So what's left is, yeah, just use the network functionality in trusted networks. If you use WaveLAN, be sure your WaveLAN is secured, which means do not use WEP, use WPA, and also use a secure passphrase. And again, make sure your WaveLAN is trusted. Okay, so that's more or less it. There are some conclusions. So yeah, nearly every modern high-end DSLR now features a full-blown TCP/IP stack and also services to access the camera, which are, yeah, let's say more or less weak. Also, once more, this shows that embedded devices and their network implementation are not designed with too much security in mind, and this leads to a class of new attacks for a class of new devices.
Yeah, everything's moving to the cloud now.
So, and we're not done yet, because Canon, in the meanwhile, released a new camera model, the EOS 60. This one also features a built-in wireless access point. And there is a new communication mode used for the iOS or Android app to communicate with the camera. So this definitely will be our next target, but I haven't managed to get my hands onto an EOS 60. Anybody got an EOS 60 here? Please raise your hand. I won't brick the camera. Okay, so as there's never time enough, thank you for your time, and any questions? Yeah, the question was, is it able to patch the firmware? By the way, cheers. Yeah, there are firmware updates. In the time I own the camera, there have been 2 or 3 new firmwares released by Canon. But to apply the firmware, you need to turn it onto the CF card, plug in the CF card into the camera, and then manually launch up the update utility from the camera's menu. But all the updates I applied, this is running the latest, greatest firmware. All the updates I applied are only addressing some usability stuff, like, okay, the autofocus now is a little bit faster, and the light's blinking red instead of black, and stuff like that.
And the shutter sounds more like an icon.
No, that's not in software. So yeah, there is the ability to upgrade the firmware. We didn't have a look at the firmware itself, so we just addressed the network services with this one. Okay, the question was if once I downloaded the images from the camera, if I'm able to delete them. Yes, I am. They're turned off by default. You need to turn the camera into the special mode. So you need to enable the network feature and you need to select one of the 4 modes.
What about reformatting the disk?
The battery format? No.
Reformatting the disk.
Oh, the disk actually is the CF card plugged into the camera. And I'm not quite sure if I can format the card, but I can delete all content, which is more or less the same. Yeah, but there might be some Canon proprietary extension to the PTP-IP protocol which allows me to format the camera.
Yeah, and I don't think the standard Paparazzi is capable of forensic stuff like recovering files from a CF card.
It's some kind of a Canon owns real-time operating system. So I just called it the Cam OS in the slides. I think the official name was
no idea.
something like,
Isn't it cameras?
I think, was it Cam OS?
I guess.
Okay,
I think so.
I think it's called Cam OS, but it's Canon's own operating system. So, okay, yes?
Have you talked to anybody or seen just how often these settings are the way they are in real life? Like, I don't know, do Paparazzi actually leave these settings on?
They are used in the wild, those network features. Yeah, I got a picture in the, no, it's in there. In the beginning there was a picture from this one, the Reuters image. There are like 5 1D bodies on the top and 3 of them got the wireless file transmitter attached. So this feature is used and it will get used more in the future because once you're able to connect your pretty iPhone to the camera, you will do it. Yeah.
Last question?
Okay, so last question. Yes?
Speaking of iPhone, what if you were to use the camera and so you said it Bluetooth as well, right?
Yes.
You can actually get into the camera and then hop over to the iPhone and pair with it, for example, and start talking. Some damage there.
Okay, question was about the Bluetooth capability. I've only been able to connect a GPS receiver via Bluetooth. I think the camera isn't capable of any other Bluetooth protocol. Okay, so thank you all for being here this early. Maybe see you at Troopers.